In this video, we're going to be looking at the quadratic formula again, but specifically a certain part of the quadratic formula known as what we call the discriminant. So recall that when we talk about the quadratic formula, we're saying we have some quadratic function that's written in standard form and equal to 0. If we want to find the x values that cause this to be true, then we say the x values are always equal to this quantity right here, where we have x equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. Now, the thing I want to kind of comment on in this video is this part right here. And this is the part that we're going to give this name. We call it the discriminant. Discriminant. And the discriminant is kind of a nice thing because when you're solving quadratic things, let's just pretend that I get an answer that is negative b plus or minus some positive number in here all over 2a. The fact is we can take the square root of a positive number and what we'll get is actually we get two real answers. And if we were to do negative b plus or minus the square root of some negative value in here, 2a, what I can say is this: I know that I would get two answers, but it would involve some imaginary thing right here. So we say 2 imaginary. Okay, and as per our last video, as a matter of fact, we said, what if I got a discriminant value of just not positive, not negative, but some neutral number? We say 0 is a neutral number. What I actually get is this. This would be the same thing as negative b plus or minus 0 all over 2a. And so we'd say, just ignore this. I really get one real answer, one real root. And so what we're going to basically kind of outline here is this. Noticing just by looking at the discriminant, what can we say about the nature of the roots of this parabola, okay? So it says, by determining the sign of the discriminant, we can comment on the nature of our parabola and the number of types of roots it'll have. So I kind of make a little key here, same thing I kind of did over here, but it says if our discriminant, that b squared minus 4c, if it's greater than 0, in other words, if it's positive, then the equation has two real solutions. As a matter of fact, we kind of outlined that here. We said, well, what if b squared minus 4ac equals 0? What if this stuff in here is equal to 0? Then we're going to get the same answer, but we're going to get it twice. So we get one real solution, but it's a double root. And then just like at the end of our last video, we say if b squared minus 4c is negative, then the equation has two imaginary roots. That is, we would get two imaginary roots because we'd have to put an I out front to get rid of that negative inside of our square root. So what we're going to do is this. We're going to use the discriminant to determine the number and type of roots of each of the following quadratic equation. So what I've given you is this, 3 different graphs that are all very similar. You notice that actually if you take a look at all these, the only thing that's different about them is their c values. But I do not want to go through and find the x-intercepts. I just want to know, just by looking at this, could I quickly tell you how many roots it has and what kind of roots they are? So what we're going to do is we're actually going to do this. We're going to find the discriminant value now. We're going to find this discriminant value now, which is this b squared minus 4ac part. Now I'm going to tell you, looking at this, we get an a value of 1. Looks like we have a b value of negative 6, and a c value of 10. So if we plug these in, we say negative b squared, so we get negative 6 squared minus 4 times a times c. My question is, does this come out to be positive, negative, or what? So our discriminant value comes out here to get a positive 36 in front. A negative times a positive is a negative, and 4 times 1 times 10 is 40. So in this case, we get a discriminant value of negative 4. That is, when we do the quadratic formula, this thing right here is less than 0. So what this means is, since we have less than 0, this means when I do a square root of this, I'm going to be doing the square root of a negative, you guys. And so if that's the case, then what we get are we get two imaginary roots, or x-intercepts. Which means they don't have any x-intercepts. And I just want to prove this. If we go graph this, this was x squared minus 6x plus 10. Let's get this out of here. We say, what does this look like? X squared minus 6x plus 10. You'll notice that we get this parabola right here that never hits the x-axis. So now what I want to do is in this next one, what if I made this x squared minus 6x plus 9? You know, if I go back and graph this with a 9. You can see that my graph shifted down, but this actually has a real x-intercept, and it occurs at 3. So we say, could I have been able to tell this just by, determining the discriminant prior to doing this? We say, yeah, you know what, let's do b squared minus 4 times a times c. And in this case, we get b as negative 6 squared minus 4 times a is still 1, and our c value is 9. You can see that in this case, we get 36 minus 36, which is 0. In other words, we're going to be taking the square root of 0, so we get one real root. And the reason why, again, is because, look, I mean, supposing we look at the graph, we say, I can see that it has one real root here. And also because when we talk about plugging in a 0 inside this radical right here, we're just going to get the same answer twice when we do the quadratic formula. So last but not least, if we change that plus 9 to a plus 8, which, by the way, this shifts our graph down, you can see that it's pretty convenient. We're going to get two real roots at 2 and 4. But essentially, we can say, what are these roots? We'll just go find the discriminant value right now, b squared minus 4ac. We need it anyways if we're going to do the quadratic formula. So we get negative 6, a is 1, c is 8. So I get 36 minus 4 times 8 is 32. So I get this positive 4. And the point here is it's positive 4. It's greater than 0. So since the discriminant, I'll write this out, the discriminant equals 4, and that's greater than 0, then we get two real roots, or two real zeros, or two real solutions, but only because when we take the square root of a positive, we'll actually get some real numbers that goes with this. So that is what the discriminant is. It's this inner portion, and we can look at it, and just by telling whether it's positive, negative, or 0, what kind of solutions we're going to get, and what the nature of our graph.